All right, back to the iPad land, and we should hopefully have Fermat's statement out in front of us. So here's where I'm making the overarching assumption that P should be an odd prime, just so I don't have to deal with 2. And then my claim is that my P is going to have this decomposition of x squared plus y squared for some integers x and y. We can assume that they're probably going to be positive as well, if and only if my prime was in fact a 1 mod 4. So we can see that 5 is a 1 mod 4, therefore 5 will have a decomposition. 13 is a 1 mod 4, therefore 13 will have a decomposition. And that process, again, works forwards and backwards. If you have the one, you'll automatically get the other one. The forward direction of this argument is actually kind of dumb. It's kind of like an old school homage to like Math 201 or this intro to discrete math. If you remember some of those in the back of your brain, it's basically a parity argument. If you give me some prime that has this decomposition of x squared plus y squared, my hope then is to see that that prime is actually going to be a 1 mod 4. So it's that kind of green reverse arrow. Well, if you look back to our big laundry list of things, and again, not paying attention to 2 because 2 is dumb, if you look at the rest of those decompositions, you will see that exactly one of those perfect squares is even, and one of them is odd, which has to happen because the sum of those 2 perfect squares, if they had the same parity, would end up being an even number. If you take 2 even perfect squares, add them together, it's going to be even. If you take 2 odd perfect squares, add them together, well, 2 odds added together is going to be an even, which again is not prime. So we are guaranteed to have this decomposition have 1 odd and 1 even. I don't necessarily know which one is which. Sometimes the smaller number will be the odd one. Sometimes the larger number will be the odd one. For example, in 5, I have a 1 and a 2 squared, but in 13, I have a 2 and a 3 squared. So my argument's basically going to start up is that I have my P, which is going to be decomposed as an x squared plus a y squared. Because I know P is odd, I know that one of those values in the XY pair must be odd and one of them must be even. I'm just going to assume that the first one is odd and the second one is even. If you need to flip them around, obviously just flip them around. I usually like to write them up here just with the smaller one first and the bigger one second, though you could always write them just as always putting the odd one first and the even one second, or vice versa. I just needed to have something initialized there so I could actually start calling these things something else. So I'm going to claim that the x1 is the odd one and the y1 is the even one. So they're going to have this decomposition of a 2k plus 1 or a 2l for oddness and evenness. Then when you stuff that definition in for x and y, you're going to get 2x plus 1 quantity squared or a 2l quantity squared. Well, the 2l squared is easy because that just becomes 4l squared. If you blow up the 2k plus 1, that becomes, foiling it all out. So it becomes 4k squared plus 4k plus 1, which if you stare at that thing, there's the nice little 1 that we're looking for, and everything else has a 4 in front of it. So that thing is definitely going to decompose down into a 1 modulo 4. So that forward direction is actually kind of boring. You may or may not have seen something like that back in Math 201. If you took it with me, you definitely saw some versions of that. Is that, we'd study these even and odd numbers and then inflate them modulo 2 into mod 4, which is always going to turn into these nice little zeros and ones. That's basically what's happening here, is that if you take any number that is either even or odd and you study it modulo 4, well, the only possibilities are to have remainders of 0 or 1 up in that level. And you can actually kind of see it down in this little argument, is that an odd number squared would have turned into this, which is a 1 mod 4. An even number squared is going to become that, which is a 0 mod 4, which is kind of in the back of the brain about if you were to add up a couple of these things, there's no chance that it would ever kick out a 3, which is why we have this nice little even, or this if and only if statement. But like I said before, there are a ton of different ways that you can show some of these results. I'm going to specifically lean on the lattice approach just because we have lattices and they're neat and it becomes this really tidy and short argument that doesn't have a whole bunch of weird cases that we have to consider. So I'm going to pause it here. That's my forward direction. The reverse direction will take a little bit more to flush out because we'll have to set up a few things, see some lattices. So I'll probably break it up into 2 videos just to make it not super duper obnoxious. And we'll go from there.